Okay, so this time I'll be discussing about the one sample z-test. Now, the one sample z-test is useful if we are testing whether the mean of a population is less than, greater than, or equal to some specific value. That means to say we want to assess the mean of a single population, thereby we'll be dealing with a single sample. We'll find out later on that one of the assumptions of the z-test, of course, is that the population standard deviation is known. Now, these are the types of z-test, of course. No? They can be, a z-test can be two-tailed or one-tailed. Well, madali lang guys, no? Kung paano natin ma-determine kung two-tailed ba o one-tailed yung z-test, no? Just look at the alternative hypothesis. Again, no, we denote the null hypothesis by HO and the alternative hypothesis by HA. Now, if the alternative hypothesis adopts this symbol not equal to, this is the not equal sign, then it is assumed to be a two-tailed test. On the other hand, when we have the strict inequality less than or greater than, then we have what we call the one-tailed test. Illustrate ko mamaya to guys, no, using the probability distribution, no, to illustrate yung pagiging one-tailed or two-tailed, no, nung isang z-test. Okay, when we'll be having those examples, right? Now, ito yung tinatawag nating z-test statistic. Okay, this is of course, the formula that we'll be using when we'll be conducting the hypothesis testing procedure. Okay, this is z is equal to the square root of n times the quantity x bar minus mu sub 0, or sometimes read as mu null, all over this denominator sigma. So we have here n being the sample size plus the total number of respondents, no, in the sample. X bar is the sample mean, then mu null or mu sub 0 is the hypothesized mean. Yung hypothesized mean, ito yung tinetest natin na value, no? And of course, that sigma is the known or given population standard deviation. So it's very clear guys, no, na yung z-test ay ginagamit, okay, to test the mean when the population standard deviation is given. Kung alam natin ito, no, population standard deviation. Otherwise, when it is unknown, then we have to make use of its counterpart. We call it the t-test, okay? And we'll be dealing with the t-test, no, next time. So in the process, we'll be needing what we call the critical values, okay? But of course, the critical value will be useful for us to know whether we'll be rejecting or accepting the null hypothesis. Linista ko na dito guys yung mga possible critical values, okay, responding to these values of alpha, the standard values, when alpha is 0.01, 0.05, and 0.10. In my next video, I'll be discussing how to find for these critical values using Microsoft Excel, no, or in a spreadsheet like WPS Office. So clearly, no, if our level of significance is 0.01, and this column will be for one-tailed test, and the third column will be for two-tailed test. Okay, so if alpha, the level of significance is 0.01, then this will be the critical value. So as simple as that. Actually, you can derive this critical value from a statistical table called the table giving us the areas under the normal curve. Pero since ito lang naman yung kailangan natin dun sa table na yun, so I have presented these possible values, no, dito para mas madali nyo ng ma-determine kung ano yung gagamitin. Again, no, when alpha is 0.05, then we'll just have this critical value for a one-tailed test, 1.645. Alpha is 0.10, then we have 1.28. On the other hand, when the test is two-tailed, then these are the corresponding values of, well, these are the critical values, no, corresponding to this three standard values of alpha. Again, alpha being the level of significance, right? So again, as I mentioned earlier, kailangan natin itong yung mga critical values na yun, no? For us to know whether to reject or accept the null hypothesis, right? So, what will be our decision rule, no? Or what will be our guide for us to come up with the decision? Basically, guys, depende lang yan sa sa HA, sa alternative hypothesis. So, well, clearly presented by this table, no? If our HA, when translated to mathematical symbols, when it has this not equal sign, of course, we'll be making use of the total test. Ito yung decision rule. Ibig sabihin, we reject the null hypothesis if the computed value of the z-test statistic, that absolute value there, meaning regardless of the sign, is greater than that critical value na z of alpha over 2. Ito yung makukuha sa table kanina, di ba? If you can remember, ito yung mga critical values. Okay? Ito yun kapag two-tailed, ito naman kapag one-tailed. Right? On the other hand, if the HA has this less than symbol, strict inequality, no, less than, then we'll adopt this decision rule. The test, we reject the null hypothesis when the computed value of z is less than the negative value of z of alpha. So take note of that, no? This is the negative, this should be negative, I should say. On the other hand, when we have this greater than symbol here, then we also reject the null hypothesis when z is greater than pa din the positive value of z of alpha being the critical value. So consistent naman, guys, no, yung mga symbols dito. So I think you will not be confused kasi kapag ito ay less than, dapat less than din ito, tama? And if this is greater than, then this must also be greater than. Ito lang naman yung iba, no? Not equal, so this will be the absolute value of z greater than z of alpha over 2 niya. Yan yung critical region. Okay, yan yung basis natin whether we reject or accept the null hypothesis, right? Okay, now let's have some examples. First, a manufacturer of banana chips claims that the net weight of bags sold is more than 15 ounces on average. The distribution is known to be normal with standard deviation of 3.5 ounces. A random sample of 35 bags produced a sample mean weight of 17.22 ounces. Test at the 5% level of significance the hypothesis that the population mean is more than 15 ounces. Now, let's look at the given. Here we are given what? The value 15 ounces here is what we call the hypothesized mean. It is denoted by this Greek letter mu sub 0, read as mu null. Again, no, this is the value to be tested. So in this case, 15 ounces. Okay, so this standard deviation of 3.5 ounces, well, this is now denoted by sigma. This is the known standard deviation. It says 3.5 ounces. A random sample of 35 bags, so this will be our sample size. N is equal to 35 bags, okay? Produced a sample mean weight of 17.22 ounces. So this is now the sample mean, denoted by x bar, which is equal to 17.22 ounces. Okay, using this one sample t-test. Of course, the first step is to determine the problem, no? And the problem here is the average net weight of the bags of banana chips significantly more than 15 ounces. Right, so based on this problem, we'll now formulate the null and alternative hypothesis, right? So our notation again, no, for the null hypothesis is H sub 0 or simply HO, and alternative is HA. So basically, no, again, no, in our discussion before, the alternative hypothesis shall be adapting these possible symbols, no, after translating these statements to mathematical symbols. The HA can be what? Not equal to, okay? Less than or greater than. And the corresponding HO would be what? The negation of course, not equal to will be equal, okay? If it is not the case that it is less than, then of course it must be greater than or equal to, okay? And the counterpart of this greater than symbol, of course, will be what? Less than or equal to, right? So there. So my point is, in coming up with the HO and HA, we need to, of course, consider the statements that when translated, they must be N of this, no? For HA and that for HO. Ayan. So I hope that's clear. So that this more than here, of course, will be adapted for HA. Kasi, di ba, ito yun, yung greater than dyan. So that HO now will be the average net weight of the bags of banana chips is not significantly more than 15 ounces, while HA would be what? The average net weight of the bags of banana chips is significantly more than 15 ounces. In symbols, no, starting with HA, we can have it written as this: the population mean is significantly more than, so that would be greater than 15 ounces, right? And its counterpart, HO, will be, of course, the negation of that, which will give you actually the complement. So that will be less than or equal to, okay, 15 ounces, right? So clear? So now, let's go through the other steps. No? Of course, we need to set the level of significance. In the problem, it was stated that the level of significance should be what? 5%. No? So this will be 0.05. Okay, so what will be the test statistic? Of course, it will be the z-test. Why? Because we are concerned with the mean, a population mean, and we know the population standard deviation. Again, the formula for the z-test is z is equal to the square root of n times this quantity x bar minus mu null all over sigma. So, substitute lang natin, guys, ng mga values dito, okay? And we'll be solving for z. Of course, this will be equal to square root of 35 times that sample mean, which is 17.22, minus the test value, okay, or the hypothesized mean, which is 15, all over the population standard deviation, which is 3.5. If you simplify this, you'll get this value, which is 3.752, right? So there. Now, after getting or computing the value of the test statistic, we now look at the critical region and, of course, examine the decision rule. Again, in this first problem, the level of significance is 0.05. And HA, if you can remember, adopts the greater than symbol, right? So it must be a one-tailed test. So thereby, this will be the critical value, okay? Now, take note, no? The HA there adopts the greater than symbol, so that if you are to draw the normal curve, or as our reference figure to show the critical region, okay, then this being 0 here, no? That's the mean of the standard normal random variable, okay? Then that 1.645 must be at the right side of 0, so this must be 1.645, right? And this area here is that level of significance, which is 0.05. Okay, so what will be the decision rule? Given that HA is what? The mean is significantly greater than 15 ounces, okay? So we refer to that same symbol then. So we say, well, we reject the null hypothesis if, okay, reject the null hypothesis if the computed value, the z-test statistic, is greater than yung critical value na 1.645. Again, no, as my emphasis, itong greater than dito, dapat parehas yan dyan, ha? Okay, that's my clue there. Right? So, there. So, let's now come up with our decision. Now, again, no, the computed value of the zeta statistic is z is equal to what? 3.752, right? And we'll compare this to the critical value, which is z of alpha, okay, which is 1.645. Sabi natin kanina, no? Given HA, which is mu greater than 15, i-reject natin yung null hypothesis if this were true, no? Kung masatisfy ito. But in this case, well, of course it is, no? So this is greater than that z there is greater than the critical value z of alpha. So therefore, we say, okay, we now reject the null hypothesis. So, ganun lang guys. Okay? So, what will be the conclusion then? Okay? After rejecting the null hypothesis, okay, we can now conclude that what? Ito, our conclusion will now be based on the alternative hypothesis. Then we would say that the average net weight, no? Okay, the average net weight of the bags, okay, of banana chips, no? Banana chips is significantly greater than, okay, 15 ounces. Yan. Take note guys, no? In hypothesis testing, we always make use of this word significant because it could be greater, it could be lesser, but the difference is possible, of course, not to be significant. It's actually the significance of the difference here that we're trying to test. Okay? So let's have another example. Ayan. Okay, it says here, a consumers group claims that the net volume of the products or bottles of a local soft drinks company is less than the advertised volume of 12 ounces. To validate their claim, DTI randomly selected 20 bottles and found out that the average volume is 11.48 ounces. If the population standard deviation is 4.23 ounces, is the claim of the consumers group valid at the 0.10 level of significance? Okay, so let's determine again, no, the given information there. Okay, so clearly what? This 12 ounces here will be the hypothesized mean, no? Okay. And this 20 bottles here is the sample size, right? Then the average volume based on the sample is 11.48, says here. So that is actually the sample mean, no? Denoted by X bar. So this is 11.48 ounces. Okay. What else? We have the population standard deviation, which is 4.23. Okay. And we are to test at a 0.10, okay, level of significance. Now, let's go through these basic steps, no, of hypothesis testing. Of course, we need to determine the problem, no? That's the first step there. So the problem here is the average net volume of bottles of soft drinks less than 12 ounces. Now, based on this problem, of course, we are to set the null and the alternative hypothesis, no? So once again, tingnan natin kung less than ba yan, greater than, less than or equal to, greater than or equal to, and the other symbols, no, equal or not equal, okay, as our basis to come up with our HO and HA. Bear in mind, no, I repeat, yung HA will always be adopting any of these three, no? Pwedeng not equal, so that will be for the two-tailed test. Pwedeng less than, pwedeng greater than lang, no other symbols. Okay, so clearly, since we are to determine this, no, whether this is true, being less than, so that will be our HA. So HA will then be stated as the average net volume of bottles of soft drinks is significantly less than 12 ounces. So in symbols, we'll have it written as the population mean is less than 12. Okay. Versus its complement, the average net volume of bottles of soft drinks is not significantly less than 12 ounces. Not significantly less than meaning it can be greater than, can be equal. So hence our HO will be mu is greater than or equal to 12. Okay, right? Now for the succeeding steps, again the level of significance is 0.10. So this is our alpha. Okay, and of course the test statistic is the z-test, once again, because we are given the population standard deviation. Now we'll compute. So once again, the formula for the z-test is, well, z is equal to the square root of n times this quantity x bar minus mu null all over sigma. So we'll just substitute the values here, n being 20, okay, and x bar being 11.48, and mu null is 12, right? And sigma, the given standard deviation, is 4.23. Okay, so if you'll compute for this, after simplifying, you'll get this value of negative 0.5, okay, 498. Now let's examine what will be the critical region, and of course what will be our decision rule, right? So note that the level of significance being used is 0.10, right? And it is one-tailed, okay, because of that HA, adopting that greater than symbol only. Okay, I mean less than. Okay, this is less than, right? Ayan. Okay, so therefore the critical value is 1.28. Okay, again, having the normal curve as our reference figure, okay, that random variable z having that mean, which is equal to 0, right? Now this is what? Less than, so meaning to say the left tail, okay, the critical region is located at the left tail of the distribution. So that shaded area there measuring 0.10, right? And this will be this critical value, which is z, which is negative, 1.28. So that's negative, right? So what will be the decision rule? Okay, this being negative, okay, so we say reject the null hypothesis HO if the computed value of z is less than the negative of z of alpha, right? Of course, the negative z of alpha is 1.28. Just make it negative. Okay, take note, as an emphasis again, guys, kung ano yung symbol dito, okay, dito, parehas din dun, ha? So ayan. Okay, now what will be the decision? All right, so let's come up with our decision. Once again, guys, we are to be guided by the decision rule and our HA. Take note, our HA is, okay, mu less than 12 ounces, right? So given the computed value of the test statistic and the critical value, so we would then say, well, since the computed value of the test statistic, which is equal to negative 0.5498, okay, is what? As compared to this negative z of alpha, okay, which is equal to negative 1.28. So ano ulit yung guide natin or our decision rule? Take note, we say kapag ito ay parehas lang dito, that's the time we reject the null hypothesis. However, in this case, negative 0.5498 is actually greater than this critical value, which is negative z of alpha, which is negative 1.28. So we say we do not reject HO, okay? Or simply accept HO, right? So there. So again, as an emphasis, if our HA is adopting this not this less than symbol, the critical value should be made negative, no? Dapat negative ito, okay? Negative yan. And this must also be less than for us to reject the null hypothesis. But in this case, it's the other way around. That's why we do not reject the null hypothesis. That's why our conclusion should then be what? We would then say, therefore, the average net volume of the bottles, no, of soft drinks is not significantly less than 12 ounces, okay? Or we will say that there is no sufficient evidence to conclude that the average net volume of the bottles of soft drinks is significantly less than 12 ounces, right? Now, let's have this third example. The manager of a car showroom claims that their store has been selling 10 cars per month for the past 5 years. To validate the claim, the owner of their store randomly selected 20 monthly records of sales and found out that the average sales is 11.45 cars per month. If the population standard deviation is 2.38 cars, validate the claim of the manager at the 0.01 level of significance. Okay. So then again, these are the given information. Okay, in the problem, we have here, was this 10 cars? Of course, 10 cars will be the hypothesized mean. Okay, that's the test value there. Okay. And 20 monthly records will be what? The sample size. So that will be 20. And based on the sample, according to the problem, it was found out that the average sales is 11.45 cars. So that will be the sample mean, no? 11.45 cars, okay? It says, if the population standard deviation is 2.38, so this is sigma, 2.38, validate the claim of the manager at the 0.01 level of significance. So our alpha here is 0.01, right? So we'll continue. Okay, so the first step here is again to set up the problem. Okay, so the problem here is the average number of cars sold equal to 10 cars, and then again we base the formulation of our HO and HA on this problem. Okay, so it says here equal. Okay, so it doesn't require us to identify whether it's greater than or less than. So, okay, so we are to adopt what we call a two-tailed test, no? Because this is of course non-directional. So therefore our HA will be what? Okay, it will adopt the equal sign, right? So it will be the mean is equal to 10 cars. Okay, I mean not equal to, and the HO will be the mean is equal to 10 cars. Okay, and in worded statement we would say HO is the average number of cars sold is significantly equal to 10 cars, while HA is the average number of cars sold is not significantly equal to 10 cars. Okay, ayan. Now again, the level of significance has been indicated to be 0.01, and of course the test statistic is the z-test. Why? Again, because the standard deviation is given, right? So we'll compute the z-test value. So this is now again square root of n. N is 20, okay, times the quantity, okay, x bar is 11.45 minus mu null is 10, right? All over the population standard deviation, which is 2.38. If you'll simplify this, guys, you'll get this value of z, which is 2.725, right? So yan. Again, we'll determine the critical region. No? Take note, HA is what? The mean is not equal to 10. So yan. So this tells us that we'll be adopting a two-tailed test. Again, no, with the level of significance of 0.01, so ito ngayon yung critical value. Okay? So with the reference again to this normal curve, okay, 0, no? The mean, okay? Now, for a two-tailed test, kaya tinawag yan na two-tailed kasi we have two tails of the distribution, okay, giving us the rejection region, no? Or the critical region. Yan yung sa left tail, ito naman sa right tail. Yung critical value na 2.58 na yan yung boundary dito. 2.58. Ito naman yung positive 2.58. Ibig sabihin, kapag yung value ng computed statistic is within this region, okay, we reject the null hypothesis kasi ito yung acceptance region, no? Ito naman yung rejection region. Take note, sa two-tailed test, yung alpha na 0.01 is divided into 2. That's why the left and the right tails, okay, these critical regions here will be 0.01 divided by 2, kaya 0.005 actually yung area na yan. So ito naman 0.005. Again, kapag nandito yung mga, I mean the value of the test statistic is located within this region, that's the time, okay, we reject the null hypothesis, or at this side here. Okay, that's why if you can observe, okay, the decision rule, of course, is based, no, okay, on this one. So we say we reject, okay, the null hypothesis if the absolute value of z is greater than the critical value, which is z of alpha, no? It's in this case 2.58. So yan. Clear? So there. Now, but take note, this is alpha over 2. Okay. Now, what will be our decision? Okay. Since the computed value of 2.725, of course, after getting the absolute value there, okay, compared to the critical value of z of alpha over 2, which is 2.58, so it is bigger. This is greater than. Diba? Yan yung rule. If this is greater than, then we reject the null hypothesis. Okay. So yan. Again, no, after rejecting the null hypothesis, our conclusion will then be based on HA. So we would then conclude at 99, no, with 99% degree of confidence that the average number of cars sold is, okay, what? Not significantly equal to 10. Note that not significantly equal to is tantamount to saying that it's significantly different. Ayan. Meaning to say, it can be greater than or less than. Okay? Clear? So there. So I hope you learned something from this video. In my next video, I'll be discussing about the t-test. Okay? The first case of the t-test, which is the one sample t-test. Thanks for watching.